Hello, in this video we will work the eviltwin 4x4 cube. In fact, it's not only one cube, we have two cubes in this one, and we have a limitation of movements. This is quite interesting. In fact, I searched on the web, on YouTube especially. I couldn't find a real tutorial of this 4x4 eviltwin. What I found is people who are solving it, but without explanations and without saying what is the procedure, what are the algorithms that should be used. So I think or estimate that this video is a real first tutorial. I hope it would be useful. So let's start with it. In order to be able to move it, we have to understand that this cube, it moves like this, like this, like this. This is the first cube, and there's another one here that also moves like this, and like this. So this one is solved. We will keep it solved, and we will scramble the other one here. And what we will do here, we can do it on the other one. So I will only explain how to solve this part, and the other one, it's really the same. So to be able to move this freely on three layers, we have to do like this, and then two like this. And here I blocked, in fact, the already solved cube. It is blocked, and it permits me to move this freely, the other one. Okay, I need this freedom of movements of these three. Okay, so it's like kind of this cube, in fact, but you have a limitation, like these are taped, and you only can move this part, and this part, and you cannot move other parts of the cube. So this one is simple. Once we have solved this one, and we do like this, and we get back to this situation, like this, and two. Okay, so I will scramble it. Okay, that's quite well. So what we have to do is, first we see that we have to understand that we have a center which is here white, and you have a center here which is blue. Okay, so this face turns around the center, and here this face turns around this center. First I should do the white centers. We have, in fact, if you look here, this belongs to the center. Four pieces, in fact, we have four white pieces that belong to the center, but one of them is fixed here, and the other three can be removed. So what we should do, there's no algorithm here, it's just try to put the elements of the center together. It's just kind of little strategy. Okay, generally what I do, I couple two. It helps a lot to couple two. Voila. So I got these two coupled and the other two that were coupled, and I move it like this, and I have built this center of white. Okay, so these three pieces here turn around this center, but they are considered as center. I do the same thing as in the blue face here. So the difference between white and blue is that in blue we have this center and we have this guy here is also a center, but the other centers is this one here and the other one is here. Here it is. In fact, this is only one piece, it's not two. So the active piece is this one, and this is only glued to it, and this also is glued to this. Okay, the active part is this. This is only a glued part to this. So, and this is the center, this guy here. Okay, I will put it like this. And then like this. Oh, I should not destroy what I did here. So like this. Okay. I got them. So it's kind of no algorithms, it's just to be able to assemble these together and these together. Okay, paying into attention that this is only one and this is only one piece. Okay, the second step is to put this white and blue in its correct position. To put it, it's simply like this, and like this. We got it here. Now we have to put this one here down by doing this algorithm: 2L U, 2L U prime, 2L. So I'm putting this down. Okay, and now it is, in fact, it will fit correctly here because we have blue white and white blue. But I would try to make another situation where this is not flipped correctly or placed correctly. I will flip it. Okay, so here it is. In fact, if I put it down, it will not fit correctly because I will get white, blue. I need black, white, and blue. So I put it up on the top layer again by the same algorithm. And what I want to do now is I want to flip it. To flip it, I will use this algorithm that we used on a 3x3x3, but not to flip this corner. We used it, in fact, to make a permutation or to cycle these three elements of the cross. So the algorithm was up to U, down, U, up, U, down. Okay, so we see that this piece that was, or this corner that was here, has been flipped. Also the others have been flipped, but I'm concentrating on this one right now. So if I want to flip it back, I have to repeat this algorithm. This is what I will do here. So I want to flip this. I will do up to U, down, U, up, U, down. And I have to flip it one more time. Up to U, down, U, up, U, down. And now I can put it down by 2L U, 2L U prime, 2L. It is correctly placed in its position. But I have reversed this central line. Remember that when we did on this cube for 3 by 3 by 4, when we placed a corner from the top layer to the bottom, we did like this, like this, like this. We reversed this central line. So to be able to get it back to its normal position, you have to do an algorithm. Here I can't repeat this the same algorithm because I will take it off from its position. So I will have to do another algorithm that does not affect this one here. For example, I will do the algorithm that exchanges these two opposite edges. It's 2L to U, 2L to U, 2L to U. Okay, so I keep this in its position and I exchange two edges, opposite edges, and I get this middle layer into its right position. So this is what you will do, 2L to U, 2L to U, 2L. That's it. So now we are done with this part. This is the easy part, let's say, and now we will move to the top, which is red here. The top part layer is red. So, okay, to understand how this layer is conceived, this is in fact one piece. These are not four pieces. This is only one piece. This is the active one, and all these three are glued to this one. This is also one piece, and this is the active part. This is also one piece, and this is the active part. Same here. This is one piece, and this is the active part. And this is one piece, and this is the active part. So, this is important to understand which parts are moving. So here we have to build the red cross like we do on a 3 by 3 by 3, you know. We do the algorithm which is like this, up, U, up here, U prime, down, down. And this will create this situation. In fact, I have this situation here. This is the white cross, and this is the red cross. I have to flip this and this. It's like flipping these and these. And what we do on the 3 by 3 by 3 is that we repeat this algorithm 2 times. And we get the white cross. So here I will put the red in this line, and I will do the algorithm up, U prime, down, down. And I do it another time to get these two flipped, up, U prime, down, down. And so I have the red cross. Here it is, like this guy and this guy. So now that we have the cross, we have to see the corners. Okay, there's an algorithm that will make the corners with the red on the top. Okay, it's the same one that I used to flip this piece. So it's up to U, down, down. Okay. Alors, here what we have to know is that we have to repeat this algorithm several times. And there are some positions where it will lead to a solution. So we should not repeat it in any sequence. We have to respect some sequences. So when we have two red here that are correct, and these two reds that are facing toward the left, I will do this algorithm one time. 2. And now what I see is that I have one corner red which is correct and 3 others that are not correct. I will put the correct one here and I will repeat this algorithm. 2 down, U up, U down. And again I will put the correct one here and I will do it once more, the same algorithm, and it will flip this red to its correct position, it will flip this one to its correct position, and it will flip this one to its correct position. So up to U, down, U up, U down. And all the corners are now correctly on with the red on the top. The next thing to do is to see if the corners are in their correct positions. I see that blue and white is correctly placed here. Green and white is correct because here is the green center, is the white center. But this one belongs to here. And this one here belongs to here. So what I have to do is to swap these two. To swap them, I will need to do a sequence of 2 algorithms, in fact, that we can see here on a 3x3x3. What I will do is I want to kick this piece from this position, put it on this layer, and then I will put it back again here with another algorithm. So in a first algorithm, I will put it down there using, for example, when we solve this, the algorithm that places one edge here. Okay, so let's say I will put the blue and white here. So I do like this. I have the blue white here, and I will put again this green and violet. I will put it here by using the algorithm that swaps 2 adjacent edges, the thing that we did on this 3x3x2. So it's 2R U, 2R U, 2R 2U, 2R 2U, 2R U, 2R U prime, 2R, and I placed it correctly here. Okay, so this is what we need to do here on this puzzle. We have to, in fact, kick this from here, put it down, and then put it back with another algorithm. So we start by the one that we do on a 3x3x3. And one more remark is that when I want to do this procedure, we have to pay attention to to have a good corner here and a bad one here. If you start the procedure with 2 correct corners or 2 wrong corners here, it will not work. So you have to start the algorithm to kick this from this position and put it up here. You have to start from the position where you have a correct and incorrect pieces here and there. So let's look at this like this, and I do like this. Here it is. The white and blue is here. I kicked it from the position where it was here. Now I will put it again here using the algorithm that swaps 2 adjacent edges. It's 2LU, 2LU, 2L to U, 2L to U, 2LU, 2L u prime 2l. I got it back here. Let's see what happens now on the red layer. So we have to build the cross again. So it's up, u prime, down, down. I have the cross. Let's see. I have this blue and white in its correct position. This is in its correct position. This is in its correct position, and this is in its correct position. Great. Now, what we will do is that we will flip these pieces to let the red be on the top. So we will do the usual. Okay, I will base on this. Okay, now when we have this situation, this will lead to several repetitions of the same algorithm, but be sure that when you start it, you put the correct ones here and the wrong ones here. So up to u, down, u, up, down. One more time. Okay, now I have the two and I have the wrong ones that are facing to the left side. I repeat it to u, down, u, up, u, down, and now I have one corner that is correct and the three others that are not correct. I put it here and I repeat the algorithm. Up to u, down, u, up, u, down. The correct one is here. I put it there and I repeat. That would be the last one. Up to u, down, u, up, u, down. And I have the red faces that are all up. Okay, so now we have to solve the edges or the elements of the cross. I see that I have here a green and here a white. The green comes here, so I will do the 2L to U, 2L to U, 2L to U. And by doing this, I have flipped this central here line. It's the same that happens when I do this. If I want to exchange these two, I do 2L to U, 2L to U, 2L to U, and I exchange these two pieces, but I reverse the middle layer. So this is the same situation. How to get it back to its normal position? All I need is to repeat the algorithm, or not to repeat, but to do another algorithm, the one that exchanges the two adjacent edges, and by doing 2LU, 2LU, 2L to U, 2L to U, 2LU, 2LU prime, 2L. And that's it. I have solved the cube. Okay. And to get it back to its normal situation, I'll do this. Okay. Okay, so in this second part of this cube, we will treat the problem of parity that we could get. In fact, we have solved the top layer, but we see that we have here still one exchange to do. And let's do it. So we will have 2L U, 2L U, 2L to U, 2L to U, 2L U, 2L U prime, 2L. Okay, I have solved this red top layer, but I have created here a situation where I have a reverse of this line. This line should be like this. So to get it back to its normal position, I have to do the same not this way. I will do the other one, like 2L to U, 2L to U, 2L to U. Okay, so I have, but I'm still in a problem because I have reversed this, but I have here one exchange to do, two opposite edges. And the problem is that there are no other edges to exchange. So if I exchange this, I will reverse this line. I will need another algorithm to get it back to its normal position. So to break this situation, we have to do something that could break it. And the thing that we do, the idea is, you see here the white centers. What we will do is that we will exchange one white with another white. It will not change the situation here, but what it will do, we will do the exchange by using the algorithm that exchanges or swaps two corners, no, not corners, two adjacent edges. So by doing it, we will not change at the end the solution of the white center, but we will break the situation that we had in the first place. So it's 2L U, 2L U, 2L to U, 2L to U, 2L U, 2L U prime, 2L. And I get the white center again. In this procedure, I have kicked this from its place. I have to put it back here. It's very simple. It's like this. Now I need to place this corner down, and to do it, I need to do the 2LU, 2LU prime, but it's not in its correct position. I have to flip it first. So it's up to U, down to U, up to prime, down. Here it is. I have to flip it again, up to U, down. And here it is. It is in its correct position. I do 2L U, 2L U prime, 2L. And to flip this, I do another time, or the 2L to U, 2L to U, 2L to U. And I have constructed these two layers. Now I move to the top. This is in its correct position. This is in its correct position. And here we got back to the problem of exchanging these two corners. This corner should be here and this one should be here, in fact. So to get them back, we have to remember the sequence of two algorithms, but before we have to make sure that we have a correct corner here and the one that is not correct here. And we start by, we will kick this from this position to the top layer, which is the red. It's now in the position of down, but it is the top for me. And then I will put it back using another algorithm. So it goes like this. Here it is. So it's here. I want to put it here. So I will do the algorithm that exchanges or swaps two adjacent edges. It's 2LU, 2LU, 2L to U, 2L to U, 2LU, 2LU prime, 2L. Okay, I got it back and I see that this corner is correct. This one is correct, but these two need to be exchanged. But before this, I see that I have to make the cross first. So remember the red cross. Here it is. And by doing it, in fact, I see that all the corners are correct now. This is correct, this is correct, this is correct, and this is correct. You just have to flip them to see that they are correct. So I do the up to you, down to you, up to you. I put the correct one here, and the 3 that are not correct will be in the right position. Up to you, down to you, up to you, down. And we see that all the red corners are in their correct positions. Now, what we see is that I have a blue here that can be exchanged with this white, and I have a yellow here that can be exchanged with this green. And that's great because I have 2 exchanges to make. The first one will reverse this central or middle line. The second one will get it back to its normal position. Okay, so I broke the parity. Remember that when I started this video, I had only 1 exchange to do here of edges. Now I have 2 exchanges, which is great. I will not have the problem of reverse of this middle line. Okay, we will start by the white and blue, so it's the 2L, U, 2L, U, 2L, to U, 2L, to U, 2L, U, 2L, U prime, 2L. This will be reversed when I do the exchange between this and that. And it's 2L, U, 2L, U, 2L, to U, 2L, to U, 2L, U, 2L, U prime, 2L. And my puzzle is solved. All I have to do now is to get this back. So I hope that I have covered all the situations that you could encounter on this type of puzzle. If you have any question, please feel free to ask. It would be a great pleasure to respond to you about all the tricks and all the problems that we could encounter on this 4x4 evil twin cube.